Hello students of Year 11 Maths General and welcome to exercise 4I, linear modelling. Now linear modelling is the process of using straight lines and their equations to model real life situations and to make predictions about the future using these equations as well. Now, as we remember, the features of a straight line are the y-intercept, which would represent the starting value in these situations, and the fact that they have a constant gradient, which represents from that starting value we have constant growth or constant decay. And just as a reminder, here's what our general form of the straight line equation looks like. Y equals mx plus c, with m being the gradient and c being the y-intercept. Alrighty. Now, when we would use linear modeling is whenever a situation can be described as constant growth or constant decay. Because if we look back at our equation, y equals mx plus c, our gradient has to be constant for the entire time. So we have to have either constant growth or constant decay. So some examples of that are a plant growing at a constant rate, so that's constant growth. A pool emptying at a constant rate, so that's constant decay. The growth of a savings account that has a constant rate of savings, so that's some constant growth again, and the payment of an interest-free debt at a constant rate. So the debt has constant decay in that case. So in all of these situations, what we have is some sort of constant relationship. It's either growing at the same rate always, or it's decaying at the same rate always. So whenever you have a situation like that, you can apply linear modeling. So these are the steps you actually need to undertake in order to do that. The exact steps will differ depending on the question, but here's some baseline steps for you. First, you need to define all the variables in question. So what your x and y axis will be, and what depends on what. So for example, cost might depend on distance traveled for a taxi. So you'd have to define c as the cost and d as the distance traveled. The next step is to construct an equation using those two variables. The third step is to use your equation to answer what you've been asked, the questions that have been asked of you. So perhaps you'll be making predictions, or maybe you're graphing the equation, or maybe you're doing a little bit of both. What exactly you do there depends on what's been asked of you. And then the final thing you need to do is to answer the questions in full sentences. Because you're talking about a real life situation, so we don't want to just see x equals 5. We want to see a sentence which says the chicken must have laid 5 eggs, for example. Alrighty, let's take a look at an example here. So a tree is 910 centimeters tall when it's first measured, and for the next 5 years, its height increases at a constant rate of 16 centimeters per year. I'm just underlining the 910 as well. Now, if this question hadn't already done so, I would have to define my variables first, but it's done that for me. It said, let h be the height of the tree, and let t be the time in years after the tree was first measured. So we've got some equation where it's h equals something with t in it. Now, A here, part A of the question says, write down a linear model in terms of h and t to represent this situation. So what we're doing is we're writing something that's of this form, y equals mx plus c, except now we're not using y, we're using h, the height of the tree, and we're not using x, we're using t, the number of years after the tree was first measured. So it's something like h equals mt plus c. I'm going to rub that out though so we can start from a point that looks quite logical. So h, the height of the tree is equal to this. So first of all, at the very first point, the tree is 910 centimeters tall. So that means the base value here is 910. It's going to start there and it only grows from there. So then 910 plus the amount that it grows by per year. So each year it grows by 16 centimeters. Okay, so to represent that, we write h equals 910 plus 16t. So when t is equal to 0, that means no years have passed, so this term isn't counted. Alrighty? But when t is equal to 1, for example, it would be 910 plus the 16 centimeters it grew in that 1 year. When t is equal to 2, so the second year, it's 16 times 2, which is 32 centimeters. So that means the height of the tree is 910 plus 32 centimeters. So that's how these equations work. It's a linear model, which has a base, a y-intercept, plus a gradient times the variable. Alrighty, so that's my answer to A, h equals 910 plus 16t. B asks me to sketch the graph showing the coordinates of the intercept and its endpoint. So remember, to sketch a graph, I need to have 2 points on that graph. Alrighty, now the first point is free for me because I have a y-intercept here. My c value is 910. So my y-intercept is 910. So that means this point exists, 0, 910. X is 0, y is 910. Now I just need any other point on my graph in order to sketch it. But B has asked me to sketch showing the coordinates of the intercept, which I've got, but also its endpoint as well. Now what could it mean by its endpoint? I'm going to have to look back at the question to understand that. So it says, a tree is 910 centimeters tall when first measured, and for the next 5 years, its height increases at a constant rate of blah, blah, blah. So that means after 5 years has passed, we're not really sure what happens to it anymore. We just have data for those first 5 years. So our endpoint will be at t equals 5, so 5 years later. So that's the second point I'm going to use. So my second point will be at t equals 5. Let's see what h is equal to. So h equals 910 plus 16 times the t value that I've just substituted in. So in this case, it's 910 plus 16 by 5. And the answer is 990. And it's 990 centimeters, of course. Just like C, the y-intercept value over there was 910 centimeters. But as a point, this is 5, 990. Alrighty, I've got 2 points, so now I can sketch my graph. And I'm going to do the sketch over here. So I've got an x-axis and a y-axis. However, my x-axis here represents t, the number of years that have passed. And my y-axis is now the height of the tree, because the height of my tree grows over time. And I just need a units here, which is not the letter A, it's centimeters. Alrighty, let's mark some points on our graph. So my x-axis only has to go up to 5, so that'll be quite easy to do. I'll just mark in equally distant points, 1, 2, 3, 4, 5, and then I'll put the 6th point in as well. And I'll label those 1, 2, 3, 4, 5, 6. Alrighty, now my height, my h-axis or my y-axis, it has to go from 0 up to 990. So I'm going to make my very top point be 1000, and then I'll just sort of work from there with what sort of space I need. So if this is 1000, halfway is 500, and then that's 250. Halfway between 500 and 1000 is 750. And then I can label my points quite clearly from there on. So my first point was 0, 910. So now I've got to be quite careful between 750 and 1000 where 910 will lie. So halfway between 1000 and 750 is 875. So let's mark that in. Okay, there we go. That's 910. Now, my second point is at 5, 990. So that's 1, 2, 3, 4, 5. And then I go up in my y-axis or my h-axis almost all of the way up to 1000. So that will be about there. Now I'll label both of these points. This is 5, 990. And this point here is 0, 910. Alrighty, I've got my 2 points. Now I need to join them up as well with a straight line. And this will be easier in your exercise books because you can use a ruler much more easily than I can on the screen. There we go. There's my straight line. I know it's a little bit rough, but there it is. I've labeled both of my points, both of my endpoints. And now I just need to label the line itself as well. So that's h equals 910 plus 16t. So that's part B. I've done my sketch now as well. Finally, part C says use the model to predict the height of the tree 4.5 years after it was measured. So let's just start by writing down our model once again. It's h equals 910 plus 16t. Alrighty, there's our model. Now they're asking us after the height of the tree after 4.5 years. So they're asking us for at t equals 4.5. Because that's the point 4.5 years after it was originally measured. So to find the answer here, I go h equals 910 plus 16, and then I replace the letter t with 4.5, because I'm looking for 4.5 years after the original point. My calculator can handle this all in one go, and the answer I get is 982 centimeters. However, my final step is to answer in a full sentence. So my full sentence would say 4.5 years after first measurement. Oops, sorry. The tree was 982 centimeters tall. There we go. Let's try another example now where we're interpreting a graph that's already been drawn for us. So this graph here is described in the question. It says the value of new cars depreciates with time. And the graph shows how the value, V, in dollars of a new car depreciates with time t. So I've got my value axis and my time axis. And here, see, we start off somewhere up here in between 30,000 and 25,000 at a high value, and then our value decreases over time. It goes down. So that's our graph, and we'll just answer the questions that have been asked of us. So A says, what was the value of the car when it was new? So when the car was new, that means 0 years had passed. So that's the very starting point there. Now that point on our graph, it looks like it's halfway between 30,000 and 25,000. It looks almost exactly halfway. So let's say 27,500 because that's the halfway point between those two. Now B says, what was the value of the car when it was 5 years old? So when it was 5 years old, we're looking for the point where the t value is 5, so 5 years after its initial purchase. So 5 years after its initial purchase is the point there that's been marked on the graph for us. And if we read across 5 years, it says $15,000 was the value. $15,000. Okay, now for C, we need to find the equation of the line in terms of v and t. So v is our y-axis, so it will be v equals something that has t in it. But in order to make this line, just like for any straight line function, we need to know the y-intercept and the gradient of the line. So our y-intercept was actually the answer to part A, as well as what we saw here. We saw that the y-intercept is at halfway between 25,000 and 30,000 at 27,500. Now our gradient, in order to find the gradient, we need to have 2 points on our line. So we've got this first point up here at 0, 27,500. And now we've got a second point here at 5 in the x-axis and 15,000 in the y-axis. Now, because we've got that point, we can calculate a gradient. So in our, and just to remind ourselves, gradient's equal to rise over run. So let's take a look at our rise. In our y-axis, we started off at 27,500 and we fell down to 15,000. So that means we've lost 12,500 because that's the difference between those two numbers. But remember, this is classified as rise in our equation, and this isn't a rise. We haven't gone up by 12,500. We fell down 12,500 to get there. So it's a negative rise. And our run is we've gone from 0 on the x-axis up to 5 in the x-axis. So that's the run on the bottom of our expression there. Now on our calculator, that works out to be negative 2,500. So what that means is the gradient of my line is negative 2,500. Now we've got our y-intercept and our gradient. We can actually write our equation here. So therefore v is equal to this. We've got our base value of 27,500 because that's how much the car starts at. That's our y-intercept. And then each year it decreases in price by 2,500 because that's the gradient. So each year we subtract 2,500 from its price. So that means we need 2,500 t in our equation there. So our expression is 27,500 minus 2,500 per year. And that's what t represents for us. So that's the answer to C. Now D says, at what rate does the value of the car depreciate with time? That is, by how much does its value decrease each year? And that's the gradient of our line. We've already worked that out. So that is $2,500. Sorry, let's write this in a full sentence. So the car's value decreases by $2,500 each year. Alrighty, excellent. Now E finally says, when does the equation predict the car will have no value, i.e. a value of 0? So we're looking for V equals 0 at T equals question mark. So we're looking for what value of T, i.e. how many years have to pass before the value of our car is 0. So let's write our equation. It's V equals 27,500 minus 2,500 T. And now on the next step, we're replacing V with 0 because that's what we're looking for. We're looking for what T value makes V equal to 0. So 0 equals 27,500 minus 2,500 T. So let's subtract 27,500 from both sides in order to get it off this side and get us closer to getting T on its own. Minus 27,500. So we've got negative 27,500 is equal to negative 2,500 T. So now I divide both sides by 2,500. Because that cancels them out on this side, and we'll see what we're left over with on the other side. So negative 27,500 divide negative 2,500. The negatives, of course, cancel. And I'm left with 11. So what we're saying is, after 11 years, the car is predicted to have 0 value, i.e. it's predicted to be worth nothing. Now, this is actually interesting because we're predicting after 11 years the car will sell for $0. That's not a realistic prediction, but it's what our equation has told us. And the question just asked for, when does the equation predict the car will have no value? It's quite possible that there's no point in time where the car will have no value until it eventually gets scrapped completely. Alrighty, thank you guys. That's been exercise 4I on linear modeling.